Good morning, all of you. I am Priya Sharma, PC Department, SIRT College, Bhopal, Sejanandam. The next topic of our unit first microwave engineering is TWT, stands for Traveling Wave Tube. The contents of this presentation or the video lecture is introduction, principle and construction, operation, performance characteristics, and applications of traveling wave tube. Coming to the introduction, that traveling wave tubes are the broadband microwave devices which have no cavity resonators like klystrons. Amplification is done through the prolonged interaction between an electron beam and radio frequency RF field. Now, coming to the principle, that TWTs are broadband devices in which there are no cavity resonators. The interaction space in a TWT is extended and the electron beam exchanges energy with the RF wave. Now, over the full length of the tube, the TWT makes use of disturbed interaction between an electron beam and a traveling wave. To prolong the interaction between an electron beam and the RF field, it is necessary to ensure that they are both traveling in the same direction with nearly the same velocity. So its construction consists of an electron gun, which is as used in the klystrons, which is used to produce a narrow constant velocity electron beam. This is an electron beam which in turn passes through the center of a long axial helix. A magnetic focusing field is provided to prevent the beam from spreading and to guide it through the center of the helix. Helix is a loosely wound thin conducting helical wire which acts as a slow wave structure. The signal to be amplified is applied to the end of the helix adjacent to the electron gun. The amplified signal appears at the output and the other end of the helix under appropriate operating conditions. Coming to the principle, electrons emitted from the cathode are accelerated by potential difference between the cathode and the anode. An electron beam is formed and focused in the electron gun region to be injected into the slow wave circuit where it interacts with the propagating RF wave. The axial phase velocity of the RF wave is delayed by the slow wave circuit such that it is almost the same velocity as the electron beam. As construction, I have already told you that the TWT is a cylindrical structure which contains an electron gun from the cathode tube. It has anode plates, helix, and a collector. An RF input is sent to one end of the helix and the output is drawn from the other end of the helix. An electron gun focuses an electron beam with the velocity of light. A magnetic field guides the beam to focus without scattering. The RF field also propagates with the velocity of the light, which is retarded by a helix. Helix acts as a slow wave structure. Applied RF field propagated in helix produces an electric field at the center of the helix. The resultant electric field due to the applied RF signal travels with the velocity of light multiplied by the ratio of helix pitch to helix circumference. The numerical from this statement is many a times has been questioned in the final exams of the RGPV. The velocity of electron beam traveling through the helix induces energy to the RF wave on the helix. So this is the basic construction of the helix and this is the schematic arrangement. The operation of the TWT is when the applied RF signal propagates around the turns of the helix, it produces an electric field at the center of the helix. The RF field propagates with the velocity of light. The axial electric field due to the RF signal travels with the velocity of light multiplied by the ratio of the helix to the helix pitch to the helix circumference. When the velocity of electron beam traveling through the helix approximates the rate of advance of the axial field, then interaction takes place between them in such a way that on an average, the electron beam delivers energy to the RF wave on the helix. Now, coming to the operation, the anode plates run at zero potential, which means when the axial electric field is at a node, the electron beam velocity remains unaffected. When the wave on the axial electric field is at positive antinode, the electron from the electron beam moves in the opposite direction. This electron beam accelerated tries to catch up with the late electrons, which tries to encounter the node of the RF axial field. I think this is disturbing something. At the point where the RF axial field is at negative antinode, the electron referred earlier tries to overtake due to negative field effect. The electrons receive modulated velocity. As a cumulative result, a second wave is induced in the helix. The output becomes larger than the input and result is, of course, the amplification. So, thus the amplified output is obtained at the output of TWT. The axial phase velocity is obtained by Vp is equals to Vc into pitch upon 2 pi r, which I have told you earlier. That direct question has been asked many a times. Numericals have came in the examination from this formulas. Where r is the radius of the helix, as the helix provides least change in the phase velocity, it is referred over other slow wave structures for TWT. In TWT, the electron gun focuses the electron beam in the gap between the anode plates to the helix, which is then collected at the collector. Now coming to the performance characteristics, the frequency range lies between 0.5 to 95 gigahertz. The output power is 5 milliwatts when operated at 10 to 40 gigahertz, known as low power TWTs. If operated at continuous waves, 250 kilowatt at 3 gigahertz, known as high power TWTs, 10 megawatts pulsed at 3 gigahertz. Efficiency lies between 5 to 20%. Noise figure is 4 to 6 decibels. For low power TWTs, it is 0.5 to 16 gigahertz, and 25 decibel is the noise figure for high power TWTs at 40 gigahertz. Coming to the application portion, it is used in low noise RF amplifiers in broadband microwave receivers, repeater amplifier in wideband communication links, and coaxial cables. Due to long term, TWT is used as power output tube in communication satellites. Continuous wave high power TWTs are used in troposcatter links. Airborne and shipborne pulse high power radars, ECM ground based radars used as a TWT. That's all for the TWTs and traveling wave tubes. Thank you so much. I hope so that you have understood the topic. Please like and share this topic, this video lecture to whom we to the students who needed this stuff for their final exams. Thank you. Sej Anandam. All the best students for your final exams.